everyone. My name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivered for a subject Microcontroller and Embedded Systems Design having code case 061, what we have covered, we have completed our unit number first, and in unit number 2 it is all about the MSP 430. So, in MSP 430 we have completed its block diagram architecture and register sets in our previous lecture. So, in today's lecture we are going to start addressing modes of MSP 430. So, these are the table of contents of today lecture. First is the introduction to addressing modes. What are the various addressing modes? What is addressing mode? Why we need addressing mode? We will discuss in this topic. After that, we will start with the types of addressing modes in MSP 430 microcontroller. What are the various types of addressing mode supported by the MSP 430? After that, we will start and at the end of the lecture, we will learn about the GPIO control. That means general purpose input output control. So, let us start with the first topic. Now, what is addressing mode? First, we will learn what is addressing mode. Actually, addressing mode defines the way in which the operands are accessed by the instruction itself. So, basically, before starting addressing mode, we should know the two things, that is opcode and operands. If we look into the instruction of any microcontroller, there are two things in any instruction. First one is the opcode and second one is the operands. Opcode basically operational codes, or we can call it mnemonics or machine codes, that tells the microcontroller that what to do with the instructions. And operands are basically the instruction to be executed on. If the opcode say that we have to move some data from one registered set to another registered set, to whom it will be operate? It will operate on the operands. So, opcode is one, there is only one opcode to tell the microprocessor or microcontroller that to what to do, and operands are two because we have to move data from one to another. So, operands may vary from 2 or in some cases 1, and in some cases there is no operand. So, there is basically in general there are two operands, source and destination. Okay. So, the term addressing modes refers to the way in which the operands of an instruction is specified. So, basically as the name implies, addressing modes, various modes to address the operands, various modes to address the operand by the opcodes. Okay. So, the addressing mode specifies a rule for interpreting or modifying the address field of the instruction before the operand is actually executed. As we are discussing that addressing modes defines the way in which the operands are accessed by the instruction itself. Instruction means opcode itself. So, what are the advantages of using addressing modes? Addressing modes give us the programming versatile because we can move the data from the memory location, from immediate data we can move, and we can also move the direct value into another register. So, it give us versatility to the user by providing such facilities as pointers to memory, indexing of data and program relocation. In further slides, we will learn how we can configure our registers, how we can move data from one register to another register. So, by using addressing modes, it will reduce the number of bits in the addressing field of the instruction. By using addressing mode, we can reduce the number of bits in the addressing field of the instruction. Okay. Now, as we have already discussed, in any assembly language programming, there are two things, opcode and operands. We should know about it. Opcode means operational codes and operand means the operation to be executed on. So, the operation will be performed on the operands and it will be processed by the opcodes. So, opcodes tell that what to do with the instruction, what will do with the instruction upon receiving by the microcontroller. So, opcode is only one because we have to give the command, and operands are two, source and destination. Okay. So, an opcode abbreviated as operational codes is the portion of a machine language instruction that specifies the operation to be performed by the any processor. So, an opcode is nothing but the processor operational codes, or we can call this mnemonics, which is designed during the manufacturing of the chip. So, operand means that the data we are operating on, the data to be operated on operands. It can be direct address of the memory, it can be register name, or it can be any numerical data to be executed upon. So, instructions are operation performed by the CPU. The instructions are performed by the CPU only. CPU will carry out the instructions. Operands are entities operated by the instruction. So, in a nutshell, we can say that addressing modes define the way through which the various operations can be act upon operands. How we can deal with the operands by the instructions, that is addressing modes. As the name implies, the different modes, different method through which we can access the instructions in a operands. Okay. Now, come to the addressing modes types. In our MSP 430, we have 7 addressing modes. These addressing modes are dedicated to source operand, and 4 addressing modes are dedicated to destination operand. Okay. So, in MSP 430, we will learn about these 7 addressing modes. First one is the register addressing mode, second one is the index addressing mode, third one is the symbolic addressing mode, fourth one is the absolute addressing mode, fifth one is the indirect register mode, sixth is the indirect auto increment mode, and the last one is the immediate mode. So, basically these addressing mode tell us that how we can execute the operands by the opcodes. Okay. So, all the data, all the things are operated on the operands by the opcodes. Okay. Now, start with the first one, that is the register addressing mode. So, as the name implies, basically we can say that in register addressing mode, both the operands are registers. So, let us come with the some previous things. In previous lectures, we have learned that in our MSP 430, we have 16 general purpose registers, 0 to 15, total 16 registers are there, okay, 16. So, in 0 to 15, from R0 to R3, it is dedicated to some dedicated task only, for example, program counter, status register, constant generators, etc. But from R4 to R15, that is 12, total 12 registers are there. These are not dedicated to any specific task, they are general purpose registers. General purpose means that we can configure it as an input as well as output as well. So, basically we can say that out of the 16 registers available in MSP 430, 12 are general purpose registers. So, these registers are only used in our register addressing modes. So, we will operate through these registers. Each register is of 16 bit. Okay. So, in register addressing modes, it will directly work on the processor registers. What we can say that R4 to R15. We have discussed that out of the 16 registers, we will use only 12 registers R4 to R15 for our general purpose. So, register addressing mode will work on the general purpose registers that range from R4 to R15. So, or on a special SFR such as the program counter, you can also use, but it is better to execute on the general purpose registers. So, they are very efficient in terms of both instruction speed and code space. Okay. So, these uses 1 or 2 of the registers in the CPU. They are only use 1 or 2 of the registers. We can say that we can take the registers from R4 to R15. We can take any registers. Okay. So, it is most of the straightforward addressing mode. Straightforward, why it is called straightforward? Because it is very much easy to operate directly from one register to another registers. Okay. So, the registers are specified in the instruction word. What is the meaning of the word? I am erasing the rest of the things. Okay. So, what is the meaning of the word? In any instruction, there are 3 things: bit is maybe 1 or 0, another one is the byte is equals to 8 bits, and word is equals to 2 bytes, or we can say 16 bits. The word is equals to 16 bits. We should know the basics before going into the depth of this topic. So, the registers are specified in the instruction word. Okay. No further data are needed. It is also the fastest mode, and the instruction can take only 1 cycle. Why it is a fastest mode? Because directly we can transfer the contents of one register to another register. We will discuss here in this instruction. So that make it to a fast as compared to other addressing modes. Okay. So let us discuss through some example. Here it is mov.w. mov.w. What is this MOV? MOV is the opcode. This is the opcode, operational codes, to tell the microprocessor or microcontroller TAD what to do with the instructions. And .w, dot is the extension and .w means the word, because it means that we are operated on the word file. So one word is equals to 16 bits, and we can say that R5 and R6 are general purpose registers, and each general purpose register is of 16 bits. So simply in this instruction we can move the data from the R5 to the R6, because R5 is the source operand and R6 is the destination operand. Unlike in 8051, on the left side there is a destination and on the right side there is source, because and the data will move from this to this direction. So it is the reverse operation. So we can say that mov.w means that opcode, it tells the microprocessor, microcontroller that to move something, and what to move from one register data to another register data. Or simply we can say that through this instruction we simply move, load or copy the contents of source register R5 into the R6. Both R5 and R6 are 16 bits. So we can say that we can accommodate all the 16 values from the R5 into the R6. Okay. So that's why we are represented W here. W represents that we are dealing with the 16 bit of data. Okay. So basically we can say that move, copy, move also move, we can say that it is load or copy the contents of source register into the destination register. So R5 is the source register and R6 the destination register. Okay. And register R5 is not affected. What does it mean? After executing this instruction, the contents of the R5 remain unaffected. Okay. So that means R5 is not affected. So this is about our first addressing mode, that is register addressing mode. Second one is the index addressing mode. Index means something displacement, some constant value to be added to the source operand. So the index addressing modes are the commands. It is formatted as X, R, N. What is the meaning? So X is a constant. It may be a displacement. That means any displacement value 3 or we can say 5, etc. And it becomes X plus Rn. Rn is the general purpose register varying from R4 to R15, as we have discussed in our previous slide. So through this instruction we displace, or we can say that we are adding some constant value to the general purpose registers. So XRN. So X plus Rn is the indexed value. So index addressing mode can be used for both source and destination. Okay, we can deal in the both way, source or destination. So index mode addressing is useful for applications such as lookup tables. If we are directly if we want to go from one value to the another value in lookup tables, we can use index addressing mode. For example, this is the MOV F000H R5 R4. What does it mean? Move is the opcode. It tells that we have to move something into our processor. F00H, it is a we can say that in MSP 430 it has a 20 addressing mode. Okay. So it has a addressability of 2 to the power 20. That means it value range from 0000000 to F, 5 times 0 to 5 times F. So we can say that this is the value. Okay. And we are moving the contents of R5 with we can say that this is a displacement value into the R4. So move copy the contents of source address. Here it becomes X plus Rn. X is the F00H. So we can say that X plus Rn means F00H plus R5. We are taking R5 as example. And two destination registers. So simply we are moving the contents of X plus Rn into the R4 registers. So let us consider, I am erasing the contents here. Suppose that R5 have the value 4 before the instruction. Okay. So we can say that MOV dot b. Why we are using dot b here? Because we are dealing with the 8-bit values. Okay, we have to specify it. It may be a 8-bit, it may be a 16-bit. Okay, for 16-bit we have to represent MOV dot extension will be dot w. Okay, so MOV dot b, 3 is a constant, 3 represent the value of the x because the index value is 3. R5 is, we can say that R5 may be any value, let us say we are considering here 00150H. Okay. So, we can say that load byte from address 3 plus R5. So, what is 3 plus R5 means 00150 and the total value is 00153. Okay. So, we are moving the value of 00153 into the destination operand, that is R6. Okay. So, this is equals to 7. If we are considering here R5 the value is 4. Okay. So, thus a byte is loaded from address, byte means dot w represent a byte is moving from address 7 into R6. The value in R5 is unchanged. We can say that after executing this instruction the value of the R5 remains unchanged. Now, let come to the third addressing mode, that is the symbolic addressing mode. As the name implies is that there is some symbolic value, there is maybe some symbols. So, what symbol we are use? We are using symbol as a pointer to the value. So, here we can say that symbolic mode allows the assignment of labels. We are assigning the labels in source operand, assignment of label to fixed memory location, and here these are the memory location. If we can say that these are the memory location from which we are moving the data, then the symbolic addressing mode will assign some labels to the memory location, so that these locations can be addressed. This is useful for the development of embedded program. If you want to execute embedded program, we can prefer symbolic mode. So, in this addressing mode, the program counter PC is used as the base address. So, the constant is the offset to the data from the PC. Let us consider that we can say that move.w, move is the opcode, we are dealing with the opcode, .w is the extension. So, .w means we are dealing with a 16-bit value. So, we are moving 16-bit value into another registers. How? Here loop control means that whatever the value we are moving, it is equals to PC plus offset value. Okay. Offset value means we are moving into the some specific address location in the vector table. Okay. So, here this is the representation of the symbolic mode. MOV means opcode, XPT pointer to the memory location, and YPT is the pointer to the memory location in destination mode. So, here we can say that through this instruction we are moving the contents of source operand, that is a pointer to the data, into the destination operand. So, move the contents of source address, so XPT is the source, that is a pointer to the data to the destination operand. So, we can say that after executing this instruction we are moving the value PC plus program counter plus some X offset value into the PC program counter plus Y. Okay. This is symbolic addressing mode. After that we have another addressing mode, that is absolute mode. As the name implies, we are dealing with some absolute memory location. So, how it represent? It is represented by through this instruction MOV and XPT and YPT. Here MOV is the opcodes, operational code, to tell the processor that we have to move something from source operand to destination operand, and XPT is the source operand, and this is the destination. So, simply if we look into the previous example, we are simply placing AND before the source operand and destination operand. If you can see that if this is the symbolic addressing mode, if we put AND here, so this becomes symbolic addressing mode. So, we are providing the simply a absolute memory address location to the previous one. So, this is similar to symbolic mode, with the difference that a label is preceded by AND. As we have discussed that we are providing AND value to the both the destination and the source operand. The word following the instruction contain the absolute address. So, it becomes the absolute address. If we are placing AND before the source and destination operand, it becomes absolute address. So, move the contents of source address, it now XPT becomes the source address, not a index value, to the destination address. Okay. The constant in this form of index addressing mode is the absolute address of the data. Now, it becomes the absolute address of the data. Okay. Not a direct value, not a index value, and not a symbolic value, okay, symbolic, some symbolic mode. So, this is already the complete address required, it should be added to a register that contains 0. For example, let us consider the example move.b. Move is the opcode, .b is the, it represents that byte value, that means 8 bits. So, we can say that there are 8 ports, there are 8 ports, okay. So, P1 in means that we are moving the 8-bit value into the R6 register. Similarly, move.b, we are moving load byte from addressing mode P1 into R6. So, basically source represents the addressing, here it represents the address P1, now it becomes address. So, we are loading the byte from address P1 into R6, okay. So, P1 is a absolute address of the registers, absolute address. Now, come to the next addressing mode, that is indirect register mode. As the name implies, indirect registers, we are not dealing directly with the values, we will deal through some memory location. So, here we will discuss with the memory location. How we can say that it represents memory location? At the rate. At the rate means we can say that some memory location, address of the memory location, okay. So, here we can say that this is available only for the source and are shown by the symbol. So, we are dealing with the symbol at the rate. At the rate means that this is address of the register R5. So, we can say that through this instruction move.w means move with the opcode, .w means the 16-bit value, and we are moving the contents of R5 at some memory location into the R6. So, now this is not a value, this is the address. So, load word from address, R5 means the address, not a value. So, how it can represent it as at the rate? At the rate of directly indicates that R5 is the value, is the address, not a value. So, we are moving someone from address R5 into the R6. So, move at the rate of R4, R5 means that we are moving the contents from memory location R4 into R5. Okay, this is indirect register addressing mode. Now, come to the indirect auto increment mode. The difference between this addressing mode and the previous addressing mode is that auto increment mode. Auto increment means we are moving the value from the particular address R4 into the R5 with auto increment. That means that at each execution the value will be incremented by +1. So, we are moving the value from source operand to the destination operand through each incrementation. So, there is auto increment mode. Auto increment means the processor will automatically increment the value after executing this instruction. So, similar to register addressing mode, here auto increment mode is there. So, this is the representation of the indirect auto increment mode, plus represents that we are incremented the value. Okay. So, we can say that this mode cannot be used for the destination. Here we cannot place plus sign into the destination. We will only incrementing the value into the source operand. Okay. So, this is the example. We are store word from R6 into the R5. Okay. This is the indirect auto increment mode. And the last addressing mode is immediate mode. As the name implies, immediate means we are directly moving the value from one operand to the another operand. So, to indicate that this is the immediate addressing mode, we will put hash sign here, hash, or we can say that some immediate value. Hash represent that it is a immediate addressing mode, it is immediate value. Okay. So, we are moving, move means this is opcode, we are moving the source operand value into the destination. So, E2 each is the constant, that means the immediate value. So, for example, move.w at the rate of PC plus R6. So, basically we are loading the immediate value into the R6, immediate word into the R6, .w means word. So, here the PC is automatically incremented after the execution instruction is fetched, and therefore, the points to the following word. At each value it is incremented by 1 and PC points to the next word. So, this is the immediate addressing mode, that is we are immediately move the data from one register to another. So, this is the types of addressing mode. Now, come to the GPIO control. GPIO means general purpose input output. Either it worked as either it work as an input as and output. So, GPIO stands for general purpose input output. So, in MSP 430 there are general purpose values available through which we can programming the we can interface the external word with the MSP 430. So MSP 430, let us consider this is the pin, then GPIO pins are available into this MSP 430 registers. So we can represent it as Px point y. Y is the bit value, x is the port value. So if we can say P 1.3, so 1 is the port value and 3 is the bit value. So particular we can say that P 1.3 means that in port 1 we are dealing with the third bit. Okay. So P 2. Y means that y is a specific pin number and port varies from 1 to x vary from 1 to 3 and port vary from 0 to 7, that is 8 bit value. So some pins are GPIO only with no specialized function. In MSP 430 some pins have no specialized function. So each port is assigned several 8 bit registers. So we will discuss what are the various registers. So there are various registers available in ports PX select and PX select 2. So as the name implies, we are selecting some bits here. So these registers selects whether the pin operates in GPIO mode or used for a specialized function. So we can say that if it is equals to 0, then it works as a specialized mode, or otherwise it is work in the 1 represent that it is work in the specialized function mode. PX dir means the direction. So this indicates that the direction of the GPIO. So direction will be represented by the 2 bits 0 or 1. If it has a value of 0, then we can say that it will work in the high impedance input. If it has a value 1, it will work in the output mode. PX out means that we are dealing with the output mode. If the pin is set to operate as GPIO pin, this selects high. High means that if there is a value 1 in the PX out, then we can say that it is works in the this will enable the pull up register, or if it has a value 0, it will work on the that is pull down registers. Okay. So PX in similarly out represents the output pin, in represents the input pin. If this pin is operate as GPIO, this pin indicates whether the voltage at the pin is high or low. So these are the registers associated with the GPIO control. These are the selected value, that is vary from, this is the LSP, this is the MSP. So it vary from selection of the pins vary from select P 1.0 to select P 1.7. This is the 8 bit register of the PX select. So the second number in the port number Y in PX point Y tells you which control bit is used. Okay. So all the registers are associated with these values. Okay. So placing a pin in the peripheral mode does not set the direction of the pin, which might be required depending on the peripheral. So basically through these pins or registers, we can configure our GPIO control and we can write the embedded C programming by using these registers. So thank you everyone. I hope you have enjoyed my lecture. Thanks.